And good afternoon, everyone, and welcome to PerfWeb Corona 30 series, week 3, day 2. We're going to jump right in for good time management. Want to thank our sponsors. Please check them out. Levanova, Siemens. These guys have been great. I want you to go to our social media. We want you to like us, follow us, and share us on Facebook, Twitter, and LinkedIn, and also subscribe to our YouTube channel and give us the thumbs up. I'm very proud of the fact we have no thumbs down. No thumbs down allowed. You can give us thumbs up. Check out our websites, perfweb.us and perfusioneducation.com. Join our faculty, suggest a topic, recommend a faculty. Just be a part of this. Be a part of this program. Be a part of this community that we're building. Because I'm just going to tell you right now, by far, we are the best and we are the biggest online resource for perfusion education anywhere in the world. So you want to be a part of it, okay? You want to email us for any reason? Seriously, you want to email us for any reason? Go to contact@perfusioneducation.com. There it is. And send us an email if you need to or like to. Also on our website, our perfusioneducation.com, you can go and do a testimonial. We hope that these programs are bringing true value, real clinical expertise to you, some very edgy topics, unique, different, not the same old humdrum. And then our call-in number, you'll see that. There it is. When you see that symbol, the phone lines are open. You can call, be live on the air. I also want to introduce now John Ingram, a staple of our program. John, thanks again for being here. You have definitely made this, helped me pull this Corona 30 off. Without you, it would have been truly impossible. So I am indebted to you eternally. Thank you so very much. John is a perfusionist extraordinaire. He's an inventor. He's published. He has owned a perfusion business. He has patented things. He is currently an ECMO specialist, perfusionist in Orlando, Florida, working at a huge ECMO center and basically supervising the ECMO specialists and managing those patients down there, helping them deliver the highest level of care. So John, once again, thank you. Thank you for being here on the program.
Hey, Joe, well, you're just a machine cranking these 15 days out like this on the Corona 30. And, I just got an email, I think it was this morning or yesterday, that the big CREF meeting, I think that's the one in San Diego, has been canceled and rescheduled for next year.
Wow.
So people are probably going to really appreciate all the effort you put into putting on this program where they can get their full 30 CEUs, right?
Well, just the Corona 30. You can get all 45 through us. You can get all of your needed continuing education coursework through us to meet your credentialing through the ABCP. Just go to perfusioneducation.com. It's a free registration. You can check it out, see how it works, all that kind of stuff. But John, at the end of the day, and we talked about this earlier, you have to have good content. You have to have a good platform. We of course, everyone's a work in progress. And as you can tell, we haven't had our system blow up again for quite a while because we have upgraded our system. The producer over there was stressing it too much, creating a lot of heat in a small box. So they had to upgrade the box to a much bigger one. And it looked like they were doing brain surgery. There were a lot of circuits and things that were taken apart by Magic, the technical guy that does that kind of stuff. And without those guys, we wouldn't have a program and their knowledge. Without guys like you who are willing to put the effort into it, some of our other faculty, of course, as well, Dr. Samir, Dr. Simpkins, who's going to be here tomorrow, Dr. Platt, who came, the other perfusionists like Mike Brown and Min Tran and Stephanie Ebus, Tammy Sparacino. But, all of you guys put a lot of effort into creating this content and, have the experience, you have the street cred, if you will, or the pump cred, whatever you want to call it, to be able to give these lectures. These aren't, this is serious business, serious information. and a lot of experience. Now, we're not doing data analysis. We're not data miners. Most of what we do, and it's always been my thing, the New Orleans conference was like that. We tend to do clinical, real world, content of experiences and things that you can take back with you, or not take back with you because you're already still there because it's now virtual, but you can use in your practice immediately. You can take that, all of what you learned, and use it immediately. I'm not big on meta-analysis. I'm not really an academic guy, but I've got 40 plus years of experience. You have 40 plus years of experience. We know a lot. We study a lot. We research a lot, and I think we both have a tremendous passion for education.
Yeah, and the person who learns the most, I'm afraid, is the people who have to try to present something. I hope the audience learns a little, but I tell you what's involved, and you know well with all the lectures you give, that in order to give a lecture and hope to appear as though you know the topic, there's a lot of work involved. There's, as you know, a lot of hours.
Absolutely. Totally agree with you 100%. And that's why I feel so indebted to you, because you have done a lot of these programs this week. And I meant it quite sincerely that I couldn't have pulled this off without you and without your help and without the help of all the other people too. But you have been a dominant force. And so I have to recognize that, and I appreciate you.
Well, you're welcome, but it's a pleasure to work with you. It's a pleasure to be on such a professional platform. You just don't find anything out there that has a platform even close to what you've put together there, and it's a pleasure to be a part of somebody that puts that much into it. It really is.
Well, thank you. Okay, so you're going to be talking today about goal-directed perfusion, and I've got the clicker.
I think I was in Houston with you about 9 or 10 months ago. I think we hit this topic. It'll be the same slides, but hopefully we've learned a little bit since then on this topic, and I don't have any disclosures on this. So, Joe, this particular, I know you're controlling the slides. This particular slides, it kind of goes line by line a lot on this one. And so just kind of watch
yes,
where
sir.
I'm at, and you'll see what happens. But before we talk about goal-directed perfusion, when I put this lecture together, I wanted to catch as many fish in this sea as possible and start with a broad net for people's wherever their understanding is, or maybe they don't even really know what goal-directed perfusion is. In fact, I think there's still quite a few people that don't. I have come to learn that a lot of the schools, perfusion schools, are teaching this and probably have been for a handful of years at least. And we're really undergoing a paradigm shift to the way we perfuse patients. And I think 5 or 10 years from now, we're going to have a lot of delivery of oxygen, goal-directed perfusion going on in the way we perfuse patients. But what is traditional perfusion? To start with, so we can understand what goal-directed perfusion means. And traditional perfusion techniques, gauge adequate perfusion according to body surface area and bypass temperature. And this is something almost all of us do all the time. And this has been shown to achieve a high delivery of oxygen in about 50% of cases, which means 50%, maybe not. So I took a little, survey on this, and if any of you are inclined to do this, just find 5 or 10 of your perfusion colleagues and ask them, can they define or what do they think goal-directed perfusion is? And when I did this 9 or 10 months ago, I was surprised. I really couldn't define it perfectly myself, and I was surprised to find out that an awful lot of people really couldn't define it either. So I didn't feel so bad, but you can ask that. And so some people said to me, well, it's AMSECT'S standards and guidelines. And so the AMSECT'S guidelines, the American Society of Extracorporeal Technology that we all know, they've created standards and guidelines based on clinical evidence and currently accepted perfusion practices. The document that they have is intended to serve as a guide for teams to develop institution-specific protocols and improve their reliability, safety, and effectiveness of their extracorporeal support services. AMSECT recommends that clinical teams use their document as a guide only for developing institution-specific protocols for their patients receiving extracorporeal support. So the answer to this is no, goal-directed perfusion is not AMSECT standards and guidelines. Well, some people said, well, it's evidence-based medicine. And that's a pretty good guess. I'm not going to answer that one right now. We're going to come back to it. But that one's getting a little bit warmer. So here's a generic definition, and this is my personal words based on all the research I did and collaborated with a lot of people who did know what it was. But the generic definition that you could take home is of goal-directed perfusion is it's providing the optimal clinical techniques, methods, and pharmaceutical treatments available to us to ensure adequate delivery of oxygen, nutrients, and fluid balance to the tissues in a clinical setting whereby the patient is no longer physiologically capable of doing so on his own. So let's do a little bit more specific definition of goal-directed perfusion. Goal-directed perfusion during bypass focuses on perfusion techniques that have been verified to achieve a high delivery of oxygen to the tissues with a consequential reduction in various ischemic-related complications. And traditionally, it's had a particular focus on reducing acute kidney injury, but it does not have to be. It can be focused on a number of things, which we're going to talk about. So how does goal-directed perfusion research studies differ from traditional research? And this is really interesting, Joe, because traditional research studies basically take a particular setting, a particular clinical or laboratory setting, and they observe the data, and they collect the data, and they strive to learn or draw conclusions from that information that they collect. And goal-directed perfusion studies, on the other hand, perform specific perfusion strategies in order to achieve a specific targeted goal. And then they assess the degree to which they were able to obtain this targeted goal. We're going to talk about this more elaborately. So getting back to, is goal-directed perfusion evidence-based medicine? Well, evidence-based practice is any practice that relies on scientific evidence for their guidance and decision-making. Practices that are not evidence-based may rely more on tradition, intuition, one's own education, or even some unproven methods. Therefore, goal-directed perfusion and evidence-based medicine practices most certainly overlap one another and are in many ways closely connected. So now, as I said, goal-directed perfusion has its backbone and its roots in delivery of oxygen, but it can be targeted, and you could have a targeted goal for many different things. And some of these things would include targeting specific hemoglobin or hematocrit results or levels, managing fluid balance and nutrition in a certain ways, managing your electrolyte balance and maybe even your blood pressure, controlling and managing your SVR and PVR, your vascular resistance, managing and controlling your blood osmolarity and protein content. You can target and manage your oxygen content of the blood, as we said, but also blood flow, cardiac output. You can manage and target arterial venous oxygen saturations and PO2s and lactate levels. But as I said, largely, and still a lot of the focus still focuses on the delivery of oxygen and, by the way, the amount of carbon dioxide produced. So we're going to look at that a lot today. So what was the premise of goal-directed perfusion and how it really came to be? Well, high oxygen delivery, DO2, during cardiopulmonary bypass is associated with better renal outcomes, less ischemic-related complications, and shorter ICU stays. But what is the best means of achieving it, and how is it determined?
John, may I ask a question?
Sure, absolutely.
Okay, so, and this is something that's very interesting to me, and I don't want to lose the thought. I'm already writing down a bunch of questions, but on this particular slide, you look at, you say that high DO2 during CPB is associated with better renal outcomes. Is that because, and I think you discussed this in one of your previous lectures, that in the glomerulus, the PO2 is so low that if you're not giving it what it needs, you have basically an ischemic kidney.
Right, and we're going to show a couple diagrams about that. And this is really what gave
I got ahead of you. I'm sorry.
birth. It gave birth to the concept of goal-directed perfusion with delivery of oxygen, especially because AKI incidence is actually pretty high when you really look at it on cardiopulmonary bypass. And going back till about the year 2000, and I'm going to talk about three in particular, really the fathers of this whole concept and all the work that they've done in the last 20 years. And when they were really concerned about the low oxygen content levels that naturally exist in the kidney, and then started thinking, well, all this AKI that we see, and not only on perfusion, by the way, in sepsis and a lot of other things, you know, maybe we should really be focusing on how much oxygen we can be delivering to the tissues. And the most sensitive, and the one that they felt would give them the most immediate gratification and data, was to look at, can we affect acute kidney injury? And they were right on when they did that. And it's turned out to be huge development in our field and in and outside of the field of perfusion, actually, when it comes to AKI.
I'll be interested to hear about it.
So did we skip a slide? I'm not sure if you go back one just for a second. Yeah, so go ahead. Yeah, you're good. All right, so go ahead. And so now what is delivery of oxygen? Let's first of all try to define this. So it's oxygen delivery is defined as the amount of oxygen delivered to the capillaries or to the tissues per minute. Well, how is it determined? Well, it has to be calculated in some way. Now, I don't necessarily say you have to do it manually, but you can do it manually. You might have an app that can do it. Nowadays, there's companies coming out with delivery of oxygen where it's monitoring certain things and doing the calculation for you. But regardless, it has to be calculated. And according to this formula, DO2, delivery of oxygen, is the blood flow or the cardiac output or your perfusion blood flow times the oxygen content of the blood. And so looking at this in more of a mathematical way, DO2 is blood flow times what is the oxygen content of the blood. That's the oxyhemoglobin, amount of oxygen the hemoglobin is carrying, plus whatever oxygen dissolved in the plasma. And of course, hemoglobin carries huge amount of oxygen, so that makes up 90% of the equation, and what's dissolved in the plasma only makes up about 3% of the equation. So looking at this in real mathematical terms, it's delivery of oxygen is blood flow times the oxyhemoglobin portion, which is 1.36, times your hemoglobin, times your saturation of oxygen, plus the plasma dissolved portion, which is just a factor of 0.0031, times your PaO2, your partial pressure of oxygen in your arterial blood that you're sending to the patient. So what are the focus points of these parameters in this equation that we can start to simplify this so we can use it? Well, there's your equation. Delivery of oxygen is blood flow in purple there, times the hemoglobin, the oxyhemoglobin aspect of it, which is 1.36, times your hemoglobin, times your saturation of oxygen saturation, plus 0.0031 plus PaO2. So those things in purple I want you to focus on. And we're going to begin to simplify this because, see, on perfusion, I mean, any one of us who are doing even modestly diligent perfusion are going to have a pretty significant PaO2. Most people run very high PaO2 now, but certainly in the triple digits, and probably not too many people running anywhere near 150 or even 150 or above. But when you run a PaO2 in the triple digits, you're going to have an arterial saturation of 99%, and you can even use 100% for this formula pretty easily. It's not going to change anything. And then you're just down to looking at what is your hemoglobin and what is your blood flow. So, and that's what I'm saying there at the bottom. And so delivery of oxygen, though, you have to look at it as an index. In other words, you have to know how big your patient is. So you always have to look at delivery of oxygen index, which is nothing more than the delivery of oxygen formula I just stated, divided by the patient's BSA. That way you know how much to deliver to a given patient whose body surface is a given size. So then it's the same exact formula we've been talking about, divided by BSA. and that gives you your delivery of oxygen index. And that's what we're going to be talking about from here forth on the lecture. How much delivery of oxygen index do we provide on bypass? Well, let's look at the normal adult at rest, normal delivery of oxygen index for an adult at rest, and it depends on what you read. Some books say between 500 and 1,000, but I'm using here 450 to 800 because if you look at normal, a healthy adult, hemoglobin would probably be somewhere between 14 and 18. On normal at-rest adults, cardiac index 2.8 to 4.0, maybe 4.2, a little bit higher even. Saturation for a normal person walking around is 90 to 92%, maybe 95%, but generally above 92, a little bit. And a PaO2 of about a 90 or a little bit greater. But let's look at what it is on bypass. So on bypass, our delivery of oxygen index is only 180 to 380. And this is measured, by the way, in milliliters of oxygen per minute per meter squared, because it's an index. Because why is it so much lower? Well, our hemoglobins, for one thing, are much lower. They're generally between 7 and 9, right? Your blood flow is less. Cardiac indexes that most of us use are 1.8 to 2.4. Your saturation of oxygen is going to be high, greater than 99 usually, and your PaO2, as I mentioned, is going to be 150 or greater. But if you plug in a variety of these numbers, hemoglobin of 7, cardiac index of 1.8, or anything in between all those, you're going to find a range of 180 to 380. So this is why we know that our normal bypass range of delivery of oxygen is about 1/3 of what normal walking around warm-bodied a person might be. It's pretty interesting to see how different it is. So there I'm saying it's about 35% of the at-rest DO2, largely due to our hemodilution, lower hemoglobin, and a lower blood flow index that we use on bypass. So why do we care about delivery of oxygen on bypass? Well, as we kind of said earlier, Joe, as you asked your question, it starts with the delicate state of our renal perfusion, low PO2 levels in the medulla, and a high incidence of acute kidney injury post-bypass. That's why we care about this. So let's look at regional variation in tissue oxygenation, basically in medullary hypoxia. Now, I have 4 research articles at the bottom there. I don't expect you to be able to read that, but if anybody wants to, you can. But I put those down there because I'm getting ready to give you 4 direct quotes from these various articles with regard to medullary hypoxia. One of these quotes from these articles down there is, kidney physiology and function are particularly dependent on oxygen supply. This effect is particularly pronounced in the renal medulla, where PO2 levels run as low as 10 to 25. Imagine PO2 of 10 or 15, Joe.
That's amazing. I've always been amazed by that.
Yeah, it's hard to believe. Therefore, it's not surprising that the kidney might be one of the first organs. Well, it turns out it is, but quoted here in the article, might be one of the first organs to be affected by a global reduction in delivery of oxygen. So in vitro studies have demonstrated that areas of the kidney are prone to ischemic injury in cases of even a slight reductions in renal delivery of oxygen. So this is 4 research articles I'm showing you here, why we care about delivery of oxygen and why we focused originally and still do on renal delivery of oxygen and the delivery of oxygen in the kidneys and acute kidney injury. So Joe, this is a slide that I stole from my own lecture probably about a year ago when I was with you there in Houston, and we were talking about acute kidney injury in general and renal perfusion in general. And what we learned, and I learned and presented there at that talk, was there's a regional variation in the tissue oxygenation of the kidney. Okay, and the blood flow to the renal parenchyma, the tissue, is inhomogeneous. So what are we talking about? The high renal blood flow is first directed to the cortex to optimize filtration and reabsorption, meaning it's going to go, when you send perfusion to the kidney, it's going to go through the nephron first. There's no way to avoid that. Well, the incoming PO2 is about 50 when it first enters the kidney.
Wow.
But then, after it goes through the nephron, there's some oxygen, PO2, that is spent on this in this blood that's lost going through the nephron. If you look to the right graphic there, you'll see the bright orange-red arteries coming in. They're oxygenated, but as it leaves the nephron, it turns purple, meaning it's losing some of its O2. That's what this graphic is trying to demonstrate. So next, the renal tissues are perfused by the efferent artery, which can carry poorly oxygenated blood. Outside of that, when it leaves the nephron, it leaves even poorly oxygenated than it came in. This is why we have borderline tissue hypoxia in the parenchyma of the tissue. This effect is most pronounced in the medulla, where PO2 levels run, as I said earlier, from 10 to 25. This is normal physiology, by the way. So how much DO2 is adequate for cardiopulmonary bypass? Now, this talk gives a tribute to the early and current. These guys are still publishing a lot of papers and giving a lot of talks, but these guys really have to be tributed as the original pioneers of delivery of oxygen. In particular, the top one there, Dr. Ranuzzi in Italy, but right along with him, Dr. Philip de Sommer and J. Trenton Magruder here in the States. A lot of them have collaborated together. We're going to look at a lot of the papers that these guys have written, and we'll see why this is such an important topic. So what has the goal-directed perfusion research, a lot of it from these three gentlemen I just mentioned, what has it taught us regarding delivery of oxygen on bypass? So here's a Ranuzzi paper, goal-directed perfusion. They took, and this was published not long ago, year 2018 in Journal of Thoracic Cardiovascular Surgery. They took 326 bypass patients, and this was at 9 different institutions. That's another thing about these gentlemen's publications, Joe. A lot of them are high volume, and a lot of them are multi-institutions. So that's why people put a lot of credibility in the research that these guys have published. So this is one study back in 2018. Go ahead. And the purpose of this study was to determine whether a goal-directed perfusion strategy aimed at maintaining an oxygen delivery of greater than 280 reduces the incidence of acute kidney injury. Now, this 280 is a number now that we know nowadays is a pretty strong number that gives us good results. Back 20 years ago when they started doing this research, we were searching for that level, and we pretty much honed in on it, being pretty close to that. So this is a 2018, and they kind of know that this is a really near our borderline of good delivery of oxygen and perhaps poor delivery of oxygen. But they're doing a study here, multi-institutions, 9 with 326 patients, and that's their purpose, to see, again, can we reduce the incidence of AKI with this delivery of oxygen strategy.
And just to clarify, that slide, it may be a typo, it says DO2, but because it's milliliters per minute per meter squared, that's actually a DO2I, is that right?
Yeah, right. It's
okay.
always going to be DO2I now. So if I've made a typo, I appreciate that. Thank you.
No problem.
So what they did, they had a goal-directed group, perfusion, goal-directed, of a delivery of oxygen, which they were going to maintain, and they did, of greater than 280. That was the strategy. And then the regular perfusion group that we normally perfuse patients with, and they just called it the perfusion strategy group. And this was based on what most of us do, is perfusion was based on body surface area and temperature. So what were the results? The goal-directed perfusion group, the one that had greater than 280 delivery of oxygen index, had an AKI reduction of 67% compared to the perfusion strategy group.
That's impressive.
So here's Magruder, one of the gentlemen I mentioned also. This is 2015, Annals Thoracic Surgery, and they were looking at the nadir oxygen delivery, the minimum oxygen delivery on bypass, and they also looked in terms of hypertension, but if it increased kidney injury risk after cardiac operations, and they took 170 bypass patients, and they matched them with a one-to-one propensity matching score. And if anybody doesn't really know what that means, they matched the patients for similar preoperative risks, similar age group, similar surgery, similar bypass times, and so on. Similar strategies as much as possible. And their purpose was to see what is the nadir, or what is the lowest oxygen delivery index on bypass that, again, indicates a risk factor for acute kidney injury. And so they actually looked back on their patients on this particular study, and they found they matched these patients one-to-one, so basically the same subgroup of patients, and they looked back and they found 85 patients, bypass patients, who developed AKI, and then they looked at 85 patients matched again one-to-one who did not, and they were trying to see, well, what was the difference here, and was the difference anything to do with delivery of oxygen? So in the non-AKI group, those group that did not develop acute kidney injury, 85 patients, versus an AKI group that did, 85 patients also, what did they find out? Well, they found out that the non-AKI group had a delivery of oxygen index on bypass over 230 milliliters per oxygen per minute per meter squared. The AKI group, who did develop AKI, averaged a 208 milliliters of oxygen index on bypass. The 30-day mortality of the non-AKI group was 5.9%, but the 30-day mortality of the AKI group, Joe, 35.3%. They found that there exists a threshold of 230 in this particular study for the development of AKI in cardiac surgery. So DeSommer and his colleagues, again, one of the gentlemen I mentioned, oxygen delivery and carbon dioxide production, which also another aspect of this you can look at is the production of carbon dioxide that's produced by the tissues during bypass as determinants of acute kidney injury. And again, it's a goal-directed study. 359 cardiac patients they took. This is back in Critical Care Journal of 2011. Their purpose was explore the association between bypass, delivery of oxygen, and production of carbon dioxide and how that relates to AKI. So a little bit more of a elaborate study also looking at carbon dioxide. It was a retrospective analysis, but it was a multi-center study, 359 patients analyzed. They looked at creatinine levels and their AKI development post-operatively. So what were their results? They identified a patient group with a minimum later delivery of oxygen index of below 262 milliliters of oxygen per minute per meter squared. Those that were above this threshold had an AKI incidence stage 2 of 7.4%. But those that were below this threshold had a 23% incidence of AKI stage 2. And this was accurate to a predictive value of 92.5%, which is pretty strong. So Ranuzzi, again, he's another paper here in 2005. And as I said, these guys have been doing this since about 2000, very late 90s, going on 20 years now. A lot of data that they've given us over those years. And he's looking at oxygen delivery during bypass and, again, acute renal failure after coronary operations. They took 1,048 consecutive cardiac surgery patients, okay, working under the premise that poor oxygenation of the renal medulla, as we discussed, during bypass may cause renal injury. They proposed that the detrimental effects may be reduced by increasing the oxygen delivery. So this is all lining up as we've been talking. Their method was they indexed the lowest delivery of oxygen on bypass and incidence of acute renal failure. So what were their results? They identified a threshold of 272 for the development of acute renal failure. So delivery of oxygen index above this threshold, those that got perfusion of 272 and above only had a 9% incidence of ARF with a 1.7% mortality rate, ARF being acute renal failure. But a delivery of oxygen index below this was a 2 to 6 fold increase and an 11% mortality rate. Magruder, again, in a pilot goal-directed perfusion initiative, looking at acute kidney injury again after bypass. This is not too old of a study, Journal of Thoracic Cardiovascular Surgery, 2017. 172 patients with a one-to-one propensity matching score. What was the purpose? The goal-directed study to determine if a DO2 index of 300 would decrease the incidence of postoperative creatinine and acute kidney injury. So, why are they using slightly different numbers? we're through the 20 years, we're trying to hone in on that exact line in the sand, that this has shown evidence more and more and more of where we should be always above and where we need to not go below. So they've tried different numbers, 230 you saw, 262, 272, here's 300. And the data comes together here closer to the end of this talk where you can be pretty sure where that real good line in the sand is, and we're going to talk about that. So go back, Joe, I'm sorry. So they looked at 300, that's what they did, and they took 88 control patients that their delivered oxygen index was 240, and 88 where their delivered oxygen index was 300. So they really wanted to see a clear difference. If there was a clear difference, and the results were, in the control group, the average creatinine went up 22% and a post-op acute kidney injury incidence of 24%. In the goal-directed group, average creatinine only went up 9%, and they had a 9% incidence of acute kidney injury. So what does all of this mean? What is the accepted threshold minimum for delivery of oxygen index on bypass? And these are the 4 papers that I just discussed and reviewed for you. And you can see there, and those papers are listed at the bottom there in fine print. Click that clicker one more time, Joe, and you'll see that this is the accepted threshold that most people use nowadays. Really somewhere right in there is the sweet spot, 262 to 272, that if you always keep your delivery of oxygen index above that, if you're going to do goal-directed perfusion, you're going to see a pretty significant improvement in your AKI. And by the way, other ischemic-related complications will be reduced also. So to be safe, what a lot of people do now is to err a little bit on the side of caution as they go ahead and use that 272 that Ranuzzi described back some years ago. So now we can look at some other things now, getting more in the weeds on this a little bit. I don't want to get too much, but I do have a few papers here. And some people look at, well, is there even something more now that we're onto this, delivery of oxygen index, and it's indicating so strongly, some of the improvements that we're seeing in AKI and other things. Maybe there's some other things we can uncover here. And the thought is, maybe the amount of carbon dioxide produced by the body is also a strong indicator, maybe even a stronger indicator. So there's a lot of research that's gone into that. And so in the human body, carbon dioxide is formed from the metabolism of carbohydrates, fats, amino acids, and is the waste product of cellular respiration. The body gets rid of excess CO2 during exhalation. Well, we pretty much know that, right? But at rest, with a tidal volume of 500, humans exhale approximately 20 milliliters of carbon dioxide per breath, or a production of carbon dioxide of approximately 240 milliliters per minute at 12 breaths a minute. So the reason I go over that is because we're going to look at what we're looking for on our patients. And so what is a carbon dioxide production index? It's the production of carbon dioxide produced per minute, of course, divided by the BSA. So let's say you have the 240, what I just discussed, of a normal healthy adult, and your BSA is 2.0, you divide that. So in normal breathing, 100 to 120, which would be the 2 divided by the 140. But produced on routine bypass, we get a carbon dioxide production of only about 32 to 50. So we're going to keep those numbers in mind, that 32 to 50 in particular on bypass as we go through this.
Is that because you're paralyzed under general anesthesia? You're not doing anything.
You know how we were only delivering about 30 to 40% of the delivery of oxygen index on bypass versus awake. It's going to go down as well with your production of carbon dioxide as well. So what has the goal-directed research studies taught us regarding carbon dioxide production index? So the reason this is important is that what we're trying to do here is, like, ideally, Joe, what we would have is some type of probe that we could, slap on our venous line or something and get a live second-to-second reading of our lactate. right? That's what we really like to know, because if we're not producing any lactate, our perfusion in all likelihood is very adequate. If we are producing lactate, we'd like to know about it right away so we can make immediate corrections. Well, we don't have such a device, right? So we're looking for ways, other ways where we can get immediate, as quick as possible, and as reliably as possible, indications that we're immediately starting to malperfuse and produce lactate. That's what we're really trying to get to here. So this known predictors of hyperlactatemia is greater than 3. That's a number that we usually use during bypass. So if you look at carbon dioxide production index produced on routine bypass, so carbon dioxide production index is usually greater than 60. But on bypass, as I said, 32 to 50 is what we're going to be looking at. So there's something called a respiratory quotient, where we can take the production of carbon dioxide and divide it by our consumption of oxygen. This gives our respiratory quotient, right? So how much oxygen we're consuming and how much carbon dioxide we are producing gives us something called the respiratory quotient. And for simplicity, you can remember it as it needs to be greater than 1. But if you really scientifically look at it, specifically, the line in the sand is 0.9, but you can kind of think of it simply as also just being 1 to 1. So it's calculated from the ratio of the carbon dioxide. And here I show you in an oxygen. And so I show you here in yellow, and this is just a slide I pulled off that demonstrated what I want to demonstrate. So just look at the yellow there, the top one. The respiratory quotient is the volume of carbon dioxide produced divided by the oxygen consumed over time. And if you look at the second yellow box there, simplified equation is, for example, aerobic respiration of glucose. It takes 6 oxygen molecules, and you end up with 6 carbon dioxide molecules, again, getting you that 1-to-1 ratio, as I was just mentioning. So there in blue at the bottom, the respiratory quotient for this reaction is 6 and 6, which basically is 1, as I was sort of saying a minute ago. So that's how they get that. So, your oxygen consumption and your carbon dioxide production is balanced, which would make sense in normal hemodynamics. So what has the goal direct perfusion taught us now with carbon dioxide index? Well, these known predictors, greater than 3 millimeters of hyperlactate, CO production greater than 60, our respiratory quotient of 0.9 or 1. And then the bottom one, delivery of oxygen to carbon dioxide production ratio, DO2 versus carbon dioxide production. And this turns out to be, needs to be less than 5. Less than 5 meaning we're not producing lactate. And so these 4 things we're going to look at on a couple studies. I know this is getting kind of involved, but they're really looking to see if we can even do better than looking at our delivery of oxygen. And so the example of that, go back one second, Jim. That example there at the bottom, delivery of oxygen versus CO2 production. So how do we get that? So let's say, we already know that we need to be delivering over 272, but in the example there, let's say you're delivering 300 milliliters of oxygen and your carbon dioxide production needs to be, 30 to 50. Well, here I just put 40, and you can see that ratio is 7.5. And so that's what we need to be. We need to be, above that 5.0 level. So DeSommer, Renuzzi, these guys collaborated on another paper here. This is in August 2011, Critical Care Magazine, or Critical Care Journal. Their purpose was to analyze correlation between oxygen delivery and carbon dioxide production, which I was just mentioning, on bypass, and see how those affected our postoperative AKI. Retrospective analysis, 359 patients, 2 institutions, monitored creatinine levels and AKI stage 1 and 2. So their results were they found that there was a definite cutoff at delivery of oxygen index of 262 or greater, and that delivery of oxygen consumption of carbon dioxide ratio needed to be greater than 5.3.
I'm sorry.
And that was a predictive accuracy of 90%. So go ahead there, yep. So in this study, same study, knowing that, or actually this is a different study, I'm sorry. So Renuzzi, another study, anaerobic metabolism during bypass, what are our predictive values of carbon dioxide type derived measures. This goes back in 2006 when they're really really hot on the trail of delivery of oxygen, but wanted to see if maybe there were other things. So keeping these 4 parameters in mind that I was talking about. Go ahead, Joe. Their purpose was to identify other predictors of hyperlactatemia during bypass. And this gets in the weeds a little bit, so don't get too hung up on this, but they looked at a whole bunch of different series of derived parameters of oxygen and carbon dioxide measured during bypass, and really searching to see if they could find even a better indicators of production of lactate on bypass. So, prospective study of 54 patients, they sampled their lactate levels, and then they also did all these calculations of delivery of oxygen and carbon dioxide consumption. And I think it's going to run down some things here. So they put in the patient's age, gender, weight, BSA, bypass time, and they made many samples throughout the bypass run. And they looked at arterial PO2 and arterial SATs and arterial CO2. They did the same thing for venous PO2 and venous SAT and venous PCO2. They looked at hemoglobin, lactate levels, what your sweep and gas flow was, what your pump flow rate was. They also looked at the exhaled carbon dioxide from the oxygenator, your ECO2, and they utilized a capnograph. It gets kind of hairy with a capnograph. I'm not going to get into that too much. It gets difficult because a lot of the oxygenators nowadays are multi-vented. All your CO2 doesn't necessarily come out of the exhaust port. But anyway, as they found, they selected to do this. They used a calculation, and if you want to know how you calculate the carbon dioxide production, there's the calculation for you. I'm not going to get too involved with that, but that's not too difficult calculation. So using this data, they used these oxygen and carbon dioxide variables. This is what they calculated. As I said, it's a bunch of things, but go ahead, Joe, it kind of runs down here.
I'm sorry.
They looked at AVO2 content difference. They looked at O2 consumption index. There's a calculation for that. They looked at the delivery of oxygen index, which we've been talking about. They kept that in there, of course. They looked at something called an oxygen extraction ratio. They looked at veno-arterial PCO2 differences, delivery of oxygen and CO2 consumption indexes, as we talked about. The respiratory quotient, as we talked about as well. So what did they find? They didn't find there was any correlation between PO2s, venous SATs, cross-clamp times or body surface area with the patients. But they did find some significant correlation between lactate production and these following things, which is what they were trying to do. They did find that the longer the pump run, you did tend to increase your lactate production just on CPV duration alone. Using the carbon dioxide index production and the oxygen delivered index, they found that there was a relationship there, and also in the respiratory quotient that we talked about, there was definitely correlation there. And this slide, don't let it get confusing. It can get a little confusing, but basically here are some more of their results. And they found patients that produced less than a lactate of 3, and they found patients that produced over 3, and they show you here what the correlations were on some of these. Bypass times, as the bypass time went up, they didn't really indicate an exact number as to where the line in the sand would be, but they found patients largely had an average bypass time 69 minutes when they had lactates greater than 3, and the ones below that tended not to. That's not an absolute. The carbon dioxide production index, remember this is what we want to have above 60, or greater than 60 is an indicator of lactate production. You can see the patients that did not produce lactate there on the left column, their average was 51, whereas patients that were above that 60, like as an average of 82, those patients were producing lactate. So that was a good indicator. The respiratory quotient, remember that's the one that we want to keep below 9. If it's above 0.9 or 1, it's going to be producing lactate, and they found that. The patients on the column on the left didn't produce lactate, had lower than 0.9, which was 0.77 on average, and the patients that did had an average of 1.35 on this respiratory quotient. index that they, and then the delivery of oxygen versus the CO2 consumption. This is the one that if it's greater than 5.3, we want to keep it above 5.3. You didn't have lactate if you were, and you did if you went below that. See there, 4.1 there. Okay, so what I did now, to get back to a little bit more something we can wrap our heads around, here's a graphic. On the left, it's acute kidney injury, the rate of acute kidney injury, and on the bottom is our delivery, our nadir delivery of oxygen on bypass, our minimum delivery of oxygen index on bypass. And I put a red line there on this graph, and if you see where the red line is, it's our delivery of oxygen index right about the 269, 270 or so, 260 or so mark. And look to the left of that. Look at your AKI rate on those dots and variance lines there. 20, 25, 30. And then when you get to near that 260 or so delivery of oxygen index, looks how it drops down to all 5. And then as you get higher delivery of oxygen indexes, it pretty much holds near that 5 or 10, with some studies varying along the way, of course. Here is the acute kidney injury rate on the y-axis on the left, with your nadir delivery of oxygen consumption of carbon dioxide ratio. Remember, this is the one that we want to keep greater than 5.3. If you look where I drew the red line, right about the 5.3 line or so, look at to the left how high the acute kidney injury is. 25, 30, 35. As soon as you get close to that 5.0, 5.3, and to the right, the acute kidney injury stays down 5, 10%. So here is acute kidney injury on the y-axis again, looking at our nadir delivery of oxygen indexes that we've been talking about so much. And there you go on the acute kidney injury on the first one there. If you have a less than 262, your acute kidney injury is 15 to 30%. When you get above 262, it drops way down between 5 and 10%. What about that delivery of oxygen versus carbon dioxide consumption, the one that we want to keep, 5 to 5.3. When you get below 5.3, it jumps 10 to 25%. You keep it above 5.3, and you're down to the 5, 10% range. So these early pioneers, what have we learned from them? What have they told us? Let's bring this all back together and put together some bullet points. They demonstrated that when delivery of oxygen during bypass falls below a critical level, and we're accepting that level now to be 262 to 272, organ hypoxia is triggered when you get below this, with consequent tissue acidosis leading to increased carbon dioxide production, and that this mechanism may be a determinant of impaired postoperative renal function. Number 2, they demonstrated that in hypoxia, cellular metabolism becomes anaerobic, and the ensuing acidosis, the result of the production of hydrogen ions within the cells, produces carbon dioxide via the carbonic acid buffer system. I'm going to point this out how this works in a minute. Go ahead, Joe. So what's happening is that we produce more carbon dioxide in anaerobic metabolism because of the acidosis. So if you look at the carbonic acid, carbonic formula, right? This is our buffer. When you have a lot of hydrogen ions, acid, coming in on the left side of the equation, it drives the equation to the right, producing a lot of carbon dioxide. That's why we have to keep that carbon dioxide level. Remember, it was supposed to be, less than 60, between 30 and 50. I said when it goes higher than that, it's an indication that we're producing acidosis anaerobically, okay? And that's what this formula is telling you. Go ahead, Joe. So now, number 3, they demonstrated that production of carbon dioxide rises above 60, what I was just saying, in the setting of inadequate delivery of oxygen, and that an escalating anaerobic metabolism is occurring, and elevated lactates will very likely ensue. They demonstrated that in hypoxia, cellular carbon dioxide production versus oxygen consumed, defined as that respiratory quotient I was talking about, has a critical threshold of 0.9, and that any respiratory quotient greater than that is highly predictive of anaerobic metabolism, and elevated lactate levels will ensue. And I think there's a number 5 there. They also demonstrated that delivery of oxygen to CO2 production ratio, that's the DO2 to VOCO2 we're talking about has a critical threshold of less than 5.3, and any value less than that is indicative of inadequate oxygen delivery. It results in increased production of carbon dioxide through anaerobic metabolism. So here's an example. Remember our cutoff, or a level we want to be above, delivering oxygen index of 270. Well, here's an example I put with the happy face there. You're delivering 320, well above. Your carbon dioxide production is well below that 60 at 40, and you're very happy, and your number there is 8, well above the 5.3. Let's say you're only delivering 240, the unhappy face there. You're only delivering 240 delivery of oxygen, and your carbon dioxide production is way up at 60. Therefore, you get the number of 4. So you get below that 5.3. It's a very good indicator of inadequate perfusion and perhaps lactate production. So Bob Groom did a lot of work on this, Joe, and he's been on top of this for a number of years. Here's a paper he wrote in 2017. But before he did this, in part of his paper, he took a little quick ad hoc survey, non-scientific, he claims it himself. And he asked people, perfusionists, as many as he could, do you measure venous oxygen saturation levels during bypass? And 85% of us, at least in his survey, do measure SVO2 on bypass, venous oxygen saturation. He asked, do you routinely measure carbon dioxide production index during bypass? And not too many people do that. I don't think I ever have. And I think it's a calculation anyway. 9% of perfusionists actually said that they do measure that index, however. He also asked, do they routinely measure PO2 levels during adult venous PO2 levels during adult bypass? And 71% of perfusionists measure PO2 on bypass. Some people don't take a venous blood gas, Joe. In fact, that's not terribly uncommon. That if everything's fine, they won't take a venous blood gas. So without that, you really can't measure your PO2 too easily. I suppose the CDI might give you that number. He also asked, do you routinely measure serum lactate levels on bypass? I know, Joe, this is an interesting topic for you. You've been talking about it recently. 43% of perfusionists, according to his ad hoc survey, said they do measure serum lactate levels on bypass. So let's look further at what his study has to do with, though. And they created at his institution a care plan that estimates delivery of oxygen based on the patient's hematocrit. So what they do is they enter in some parameters, the procedure, patient's age, height, weight, hematocrit, and they this generates a table, basically a chart, that indicates the flow that's needed at different hematocrits to maintain that delivery of oxygen index above that 270 level that we've been talking about. And they actually have here, if you look in yellow, I highlighted in yellow, and what they do is they put in the patient's, height and weight, and they get the BSA and whatnot, but then it generates what the blood flow needs to be there in yellow, what it needs to be at certain hematocrits. So they can just look at it during the case. If their hematocrit is 20%, they need to flow 5.32 to keep that delivery of oxygen above that 272 level. If their crit jumps up to, say, 28% there at the bottom, they don't need to flow the 5.3. They can flow down the 3.88, and they'll still be flowing the delivery of oxygen index of the 272. But they take this a little bit further, Joe. They actually have developed a monitor where it gives them real-time numbers. And since that monitor is kind of hard to read, I put it there in pink there on the right so you can see it better. But this is giving them real-time, on-pump, real-time data of your delivery oxygen index. That's the 303.94. By the way, way above the 272 here in this case. The consumption of carbon dioxide index, that's the one that we want, less than 50, 30 to 50. Theirs is 45, so you're not producing excess carbon dioxide, meaning you're not in anaerobic metabolism. And then at the bottom there, delivery of oxygen index versus carbon dioxide production index. That's the one we want to have greater than 5.3. And you can see here, Bob's doing 6.16. So this is redundant, reaffirming indications, real-time monitoring that they've set up at their institution. And you have every reason to believe you are solidly not in anaerobic metabolism and not most likely producing lactate. And just real quick, they also have their monitor generates this chart. And if you look there, I just put in yellow the average. I think across the top there, for example, midway through, DO2I, that's your delivery of oxygen index. If you look down in yellow, 294, well above the 272. They also have their, you see it's hard, it's kind of blocked out on my thing. That VO2 next to delivery of oxygen index, VO2 versus DO2I, that's the one that's supposed to be above 5. It's 11.85. So you can see there, again, and it gives you the maximum and minimum right above and below the yellow, the maximum minimum that they hit during the procedure, but the yellow one is telling them what they average throughout the case. On top of that real life chart that they have there. So that's pretty much, that's pretty much all I have there, Joe.
Wow.
Thank you so much.
That was what's that? Feedback.
A lot of information.
That was a very comprehensive review. Absolutely. I heard myself through the speaker. I didn't know what it was, but that was really good. I have a ton of questions. If anybody has any questions, let's open the phone. Oh, you got the phone lines open already? That's perfect. So one of the first things I want to talk about is, and you've discussed this, I learned this from you actually, that hypothermia for the kidney doesn't help you. And so when you look at these total flows that we need, you can't take hypothermia into the equation if you are looking specifically at the kidney.
Right. Let me preface this by indicating to you that everything that this goal-directed perfusion that I just covered did not discuss two things. It did not depend, your delivery of oxygen did not depend on temperature. It did not depend on blood pressure. Blood pressure is not even in the equation for delivery of oxygen. So two interesting things. So regardless of what temperature you're at, you need to deliver according to what your hematocrit is. You're not delivering oxygen if your hematocrit is low and your flow hasn't been compensated up. So with the kidney, this is critical. This is critical for two reasons. One, the main important reason is what I kind of was saying. Hopefully it was clear on the renal slide there, where the kidney works. Unfortunately, it doesn't have two different circulations. It doesn't have like our lungs, where it has a pulmonary circulation and a bronchial circulation. It has one, and it's in series. So the more blood that you pump to the kidneys, it first all has to go through the nephrons. And the nephrons will do the work of filtration, reabsorption, secretion, and excretion. And that costs a lot of ATP. That costs a lot of energy. So it's like this. It's like a package sorting plant, which I said in my previous lecture with this. Imagine the guys over at FedEx that have to sort all those boxes. What happens? The more boxes, the busier they are at Christmas time or whatever, right? Those sorters, like the nephrons, have to work even faster. So the more perfusion you give the kidney, there's no luxurious perfusion when it comes to the kidney. The more blood flow you give it, the faster and harder the nephrons have to work because they have to process all that, and it costs ATP. When the blood supply leaves the nephron, then it goes on to perfuse the tissue of the kidney, and that PO2 is always going to be lower than what it came in with on the nephron, because as I showed on that one slide, it costs some oxygen to do some of this, right? So unfortunately, there's no way to perfuse the kidney and get around going through the nephron. So you need to always deliver on a certain level of delivery of oxygen to the kidneys. Otherwise, you have no room for error in the kidneys. The PO2 is already so incredibly low. Mm-hmm. But well, that's the way it exists.
I do feel that the kidneys have been, to some degree, treated like, I guess I can say this online. I think I can. Like bastard children that aren't as thought of. An AKI is going to, especially if they go into acute renal failure, the cost to the patient, of course, is huge. the institution, and if they end up with end-stage disease, but their length of stay in the ICU, like the stay in the hospital, need for dialysis, all of those things are very stressful for the patients. And I do feel like we have I think we have two things in cardiac surgery: an unacceptably high stroke rate. Even though it's quite low, it's not as low as our mortality rate. Most people feel like a stroke is a fate worse than death, and especially the elderly population, and maybe at higher risk. But the kidney, our acute kidney injury, acute renal failure numbers are, I believe, unacceptably high. They're higher than the stroke rate, and I think that in cardiac surgery, those are the two frontiers that I think we really need to be addressing over the next, decade.
Yeah, I would encourage people who watch PerfWeb, perfusioneducation.com, your program. I want to say maybe it was PerfWeb 23, don't hold me to that. When we talked, I think the whole program practically was dedicated to this acute kidney injury on post-cardiopulmonary bypass topic. And it's pretty amazing. Part of the reason why the real research shows it's very high, actually, incredibly high. The only time you find papers that say it's not all that high is because they're not defining it correctly. And that was a big problem for many years. But now there's established clear definitions for what constitutes AKI. And when you really go by that, you're going to find, if you're, be pretty surprised how high a lot of centers find that their incidence of AKI actually is. Now, a lot of it may get resolved later in the ICU, but the damage is pretty serious. The kidneys have no tolerance for any decrease of the PO2 that they're already living on. They live right on the edge.
Yeah, AKI can be maybe to some degree reversible, and maybe the AKI is not so bad that the kidneys are maybe you just live with a 0.1 or 0.2 or maybe even a 0.3 bump in your creatinine for the remainder of your life, which is not going to require dialysis. It's whether you require long-term dialysis, and this particular chronic dialysis, where it really becomes an enormous problem. A patient who ends up on dialysis with end-stage renal disease from whatever the cause may be is going to cost the healthcare system about $100,000 a year for that one treatment of that one disease. So it's very expensive, and it's also life-altering. I mean, tremendously life-altering.
One of I don't have the study in front of me, and people can look it up. One of the real unfortunate things that happens in our field in regards to this exact topic is that we do an awful lot of patients, they do great, they do fine. They have a little bump, like you said, and their creatinine maybe for a few days, maybe even a significant bump, but it goes away and everybody says everything's fine. Let me tell you what happens. Later in life, as they get elderly, those patients on a very high percentage end up with renal and kidney failure much sooner than people who have not had that even mild incident of cardiopulmonary bypass even decades earlier.
Yeah, more likely, certainly more likely. There's no question about it, I think. The other thing, I'll tell you, this brings up another thing, and I have so much, but I'm going to try to limit it. If somebody wants to call in, please do so now. But this is why I get so exercised when I hear about people who run really they accept very low hemoglobins or hematocrits on pump. And I've seen it as low as 16. And when you do cardiac surgery and you do perfusion, we basically have a big long list of things we must do so that the patient survives this procedure. But everything that we do many times to razor thin margins because they have to do the operation. We are there to facilitate them doing the operation. And many times that means we have to be running lower flows, lower pressures. There's all kinds of things that we do in order to help facilitate doing the operation, because now the clock is ticking. The clamp is on, the heart is open, they can't see. If they can't see, they can't put the stitch in right. They don't put that stitch in right, the operation will have failed and the patient is not going to survive. So there's a very fine, it's a razor thin line. And when you sacrifice oxygen carrying capacity by reducing the hematocrit so low, and therefore your oxygen carrying capacity, you are giving yourself, you're almost hamstringing yourself, in my view, or giving yourself an Achilles heel, because you have literally no room to lower your flow. You have to be at super high flows and the field is flooded, they can't do the operation. So if you're not doing that, you are definitely not perfusing enough oxygenated blood to either the tissues in general, but especially not to the kidney. And I really do believe that.
Well, these gentlemen who've been 20 years of research now, and believe me, there's a lot more than the three that I listed here that all found the same thing. And as we talked about one time before, something about like 73% of all research studies can't be duplicated by somebody else. And believe it or not, Joe, I learned the other day that 52% of research studies can't be duplicated by the same researcher. And in this particular case with delivery of oxygen, almost all of the research has been duplicated by others. They've found that there is a critical level. You may debate it a little bit, but it's really been honed in now on that 270. But, you know, everybody who's looked at this finds that if you don't deliver a certain level of delivery of oxygen, your acute kidney injury, and by the way, this can be focused on a lot of other things, but acute kidney injury is so sensitive that it's glaring and easy to track.
Well, just like you just
is critical.
Yeah, and just like, I'm sorry. Go ahead. Forgive me. I thought you.
Yeah, I mean, there's a paradigm shift, hopefully underway. And it's taking way too long in our field, and I hope 5 or 10 years from now, if not sooner, really, if you want to be a better perfusionist, and you know, Joe, whenever I give a talk, I always try to find one thing a listener can take home tomorrow and say, what have I learned that I can be a better perfusionist tomorrow? You can be a better perfusionist tomorrow by stop flowing according to BSA and temperature and flow according to delivery of oxygen. Because there's so many of these crazy studies out there, there's way too many of them, that have focused on what is a nadir hematocrit. Well, we had a nadir hematocrit of 23, and below that everybody had AKI, and above that nobody did. So you just can't have a hematocrit of below 23. So as soon as the hematocrit gets below 23, we give blood. It has nothing to do with that. It has to do with your delivery of oxygen and what you were flowing when you had those hematocrits below 23. You can have a lower hematocrit, you just have to flow more. Now, what you're talking about
but that's
is
bad because then the kidneys have to process more blood that has a lower oxygen content. So the PO2 hitting the nephron at 30 or 25 is going, because it has less content, and no matter what, it's going to hit it at 20 instead, or 15, and now it's going to be 2 in the medulla, or lower, or 0.
Yeah, and if you're going to run low hematocrits of like some crazy thing like 16 or whatever, I mean, you better be flowing an awful high flow, and you can figure that out. But at some point is a point of no return. Maybe even then, you know, due to other reasons, your crit's so low, you know, you start losing your buffer capacity, and you start losing your ability to maybe you know,
viscosity, you third space, you get it, you know, there's all kinds of bad things that happen when you become that hemodiluted. And you look at every study done that is from the critical care side of things in the ICU, they will all tell you that fluid overload or excessive hemodilution, both, and they're independent, they're different things, but both are very bad for survival. Both of them are bad.
Yeah, very bad, yeah.
You know, and we know that. You know, and you were talking about goal-directed therapy. You know, Shoemaker is kind of the guy that started that. And then Manny Rivers, I talked about him once before, and they have found that if they can take a patient that comes into the emergency department and they can increase their DO2 significantly, and they push it up to above 750 total, 750 milliliters per minute, which would be, you know, whatever that, but higher than that, that their survival increased substantially. Now, there were downside risks. They fluid resuscitate them very rapidly because the goal is to get the cardiac output up. They need to fill the tank, so you do have fluid challenges later, but that's where treating with blood, treating with ultrafiltration, all that kind of stuff, using CVVH, which I'm a very strong proponent of or advocate of, is very important. All of these things help, and I'm a big believer on ultrafiltration on bypass. I want the hematocrit. Look, when we have a sick case, and I'm working with a surgeon who is, you know, we're in sync with each other. We agree with each other. They philosophically believe the same thing I do, and I've been able to work like this. I have always seen patients who came in with a low ejection fraction, a really weak, baggy heart, come up with very strong ultrafiltration and managing their oncotic pressure, making sure they weren't third spaced, in some ways almost drying their tissue out a little bit, making them slightly hyper-oncotic for a period of time, a lot of ultrafiltration, that those patients with a higher hematocrit have come off pump, and I mean 30, have come off pump fantastically when no one thought they were going to survive the basic operation. And it makes an enormous difference. I've seen it with my own eyes too many times.
Yeah, I agree. I've done a lot of cases like that too, because for many, many years, hemoconcentrator was just part of our tubing package. It was in our circuit every day.
Ours is too. Now, ours is too in our practice, just so you know.
Yeah.
We still believe in it.
Wow. Well, you talk the old days, I'm talking about where priming volumes were large and cardioplegia was largely crystalloid, so we almost had to. But wow, I'm impressed that you're doing that, because so many people have really, you know, gotten away from the hemoconcentrator. You know, we talked about this in another perf web where people are demonizing it, but I'm hoping that that's coming back. I don't know that it is. It would be very hard for me to gauge that, but
I mean, it's an absurd argument,
that people are learning
John,
from these.
You know, I don't want to belabor the point, but, you know, that whole thing that's being done, and I've seen the same thing, same information you have. You know, I'm sorry, I'm not trying to knock any. I'm not going to say who it is. People can look it up for themselves. But it's absurd. It's an absurd argument. There's so much data. The data is exhaustive that ultrafiltration is a very beneficial thing to do, both on bypass and in the form of CRRT with a more precise methodology in the ICU, is a very beneficial therapeutic modality for patients, both to remove fluid and manage some inflammatory mediators, but definitely for fluid management in the bypass run, but then later for clearances and basically giving the kidney an opportunity to rest.
Yeah, I would encourage people to watch. I think there was a perf web that we did on that, and we hit on that a lot. And it's just overwhelming. 30, 40 years or more of data and history of using hemoconcentrator, the enormous benefits. I think people have lost sight of. They need to recapture that. They really do.
I think so too. And I just think they should look at all resources. They should go to all the resources and look all of this information up on their own as well and learn about it and be more informed and make themselves a better practitioner in doing things that are evidence-based, that have been essentially proven with legitimate randomized and controlled and case match studies, and change their practice to be more aware of these things. Our job doesn't end because the patient left the operating room with a beating heart. We want them to go to the ICU, be extubated as soon as possible, and have, you know, all of their faculties, and normally, like they normally had, their same personality, and also have functioning kidneys. Get out of the ICU as soon as possible, get out of the hospital as soon as possible, and go back to normal life. That's our job. It isn't just to get them out of the operating room. We need to stop thinking like that.
Yeah, what about the long-term effects years and decades later? Like we were just talking about with regard to a slight hit to your kidneys now, but these people end up with the elder years of life and renal failure, part renal failure, and struggling with the problems that comes with when it all comes back down to what happened to them on bypass or in the OR, and maybe even post-operatively too. There's a lot of factors for AKI for sure, but we definitely play a big role in it, and I think we should up our game with delivery of oxygen. I think those days are coming. I'm understanding that the schools, perfusion schools, are teaching this pretty heavily and have been for a handful of years. I believe. I talk to new students and they seem to, but then they go to a place as a new grad and they're not going to rattle the trees too much and tell all the older guys, hey, I'm not perfusing according to BSA and temperature, and then they fall right back into what's been done for 100 years or 50 years and don't use that information that they were taught, unfortunately.
Very true.
Someday,
Very true, very true. Okay, so can you stick around if you want to watch my presentation? Mine's not going to take nearly as long, maybe take about 20 minutes, I think, and get through it. And then maybe we could talk a little bit about this because I'm curious about your thoughts on it. It has to do with weed. So, when we talk about weed. You've never smoked weed, have you?
No, I don't think so.
Did you have a friend that did?
I had a lot of friends that did, and I couldn't remember their names, but their names probably sounded a lot like mine at one point.
I understand. You're twin. Okay.
Yeah, I think my twin, he can tell me a lot about it. No, in my college days, actually, remarkably little. There was a time frame there. I think my freshman year, being at University of Florida, you can imagine, in 1979.
Party Central.
It made sense to try it at some point, I think, but
but you didn't inhale.
Well,
that's what matters. You didn't inhale.
Well, I tell you what, I mean, in those days, it didn't take a whole lot, and you could be okay.
Yeah, you could just get it from secondhand.
Probably, yeah.
Yeah, more than likely, I'm sure. Okay, all right. So my talk today is on cannabis, and that it's not just for getting high. So before I kind of get into cannabis, because the real question is it real medicine or is it snake oil? And so enter Clark Stanley. Clark Stanley, as you see here, made rattlesnake oil liniment. And it was good for a whole host of things. It was the strongest and best liniment known for the cure of all pain and lameness. So if you were lame, you could use this. It was only for external use, so keep that in mind. Rheumatism, neuralgia, sciatica, lame back, lumbago, I don't know what that is, contracted muscles, toothache, so I guess you could put it on the outside, sprains, swelling, frostbite, chilblains, I'm not sure what that is either, bruises, sore throat, bites of animals and insects and reptiles. It gives immediate relief. It gives it for sale by all dealers in medicine. Price is 50 cents per bottle, and it's manufactured by Clark Stanley, Providence, Rhode Island. So we've all heard, that's snake oil. And the question is cannabis medicine or is it snake oil? So I want to explore what snake oil, where that all came from. And in the 1800s, thousands of Chinese workers arrived here in the United States as indentured laborers to work on the Transcontinental Railroad. The vast majority of these workers came from peasant families in southeastern China and were signed to contracts that ran up to 5 years for relatively low wages. Among the items the Chinese railroad workers brought with them were various different medicines, including snake oil. This oil was made from the oil of the Chinese water snake. That's very important. It was the Chinese water snake, which was very high in omega-3. And of course, this reduced inflammation. The Chinese water snake oil in its original form was really very effective, especially when used to treat, the common ailments you would get from working on the railroad. They feel like they got the arthritis, the bursitis, whatever, sore muscles. So the story goes that the Chinese workers shared the oil with their American counterparts, who marveled at how well it worked. Well, eventually, Clark Stanley got wind of this mystery oil, and being the entrepreneur that he was, figured that he could make and sell the same thing. The only problem was, where could he get Chinese water snakes? So he substituted Chinese water snakes for rattlesnakes. There it is, Clark Stanley's rattlesnake oil liniment. The former self-professed cowboy claimed he had learned about the healing power of rattlesnake oil from Hopi medicine man. He never publicly mentioned Chinese snake oil at all. Stanley created a huge stir at the 1893 World's Exposition in Chicago when he took a live rattlesnake, and sliced it open before a crowd of onlookers. Of course, not only didn't these rattlesnakes contain much of the valuable omega-3 that the Chinese rattlesnake did, but they were also quite venomous. And as Clark Stanley was soon to find out, supply could not even come close to meeting demand for his miracle product, which at the time was selling very well. So what he did to resolve this was tinker with his original formula. And in comes Chief Chemist Harvey Washington Wiley, MD. By 1906, the Pure Food and Drug Act had been passed, and tough new standards were put in place to prevent the sale of adulterated foods and medications. The Department of Agriculture established a poison squad headed up by Chief Chemist Harvey Washington Wiley. They conducted stringent testing of a wide range of different products being sold in the public. This was the precursor, Pure Foods, of the FDA, which we know of today, and name was changed to the FDA officially in 1930. But because there was so much public demand and political resistance and pressure, it wasn't until 1917 when government inspectors finally seized a shipment of Clark Stanley's snake liniment and conducted a thorough analysis of its contents. What they discovered was that Clark Stanley snake oil liniment didn't contain any snake product whatsoever. According to the official report, the bottles contained a rather bizarre mixture of mineral oil, camphor, cayenne pepper, animal fat, and turpentine. While Stanley was charged under the Pure Food and Drug Act for misbranding his product, all that amounted to was a measly $20 fine. Still, the government report helped to kill the demand for Stanley's product, the snake oil liniment, and he found himself out of business. But even though the scam was found out, he went out of business as a rather rich man and faded later into obscurity. So it's very interesting, and this is actually very prescient, that in 1927, Harvey Washington Wiley, this is 1927, expressed his suspicions that the use of any form of tobacco may be or might be harmful, and that it might promote cancer. Because of mounting evidence confirming Wiley's early warnings, Good Housekeeping stopped accepting cigarette ads in 1952, 12 years before the U.S. Surgeon General issued a report detailing the health hazards of smoking. In his last year, by the way, he was the first director of the FDA, He fought and won the battle to keep refined sugar pure and unadulterated. He died in 1930 at age 86, and he was given a patriot's funeral at Arlington Cemetery. That's a big deal. This guy was serious. And the whole problem, and you're going to see this throughout my talk, is that you'll find there's a lot of this, all of what I just described to you, in the snake oil world. Did I show this on the slide? Oh, so you guys got to tell me when I mess up. There's Chief Chemist Harvey Wiley Washington. Sorry about that, guys. So, marijuana in the 1930s was considered to be a scourge. You had wild orgies and wild parties, or weird orgies. It results in lust, crime, sorrow, hate, shame, despair, misery. You see as a needle. You see the woman who looks like she's got a cigarette, assuming it's a marijuana cigarette, and her life is just ruined because she is, clearly going to weird orgies and wild parties. But when we talk about cannabis, we have to look at it from the familial and the genus, and then to the various different functional and hierarchy and dysfunctional hierarchy. So the Rutaceae family has citrus, and of course you go down, and citrus can be sweet or sour. So it can be a lemon or it can be an orange. The Cannabaceae family, which has cannabis, can have indica, sativa, or ruderalis. But when you dig down to the dysfunctional hierarchy in that cannabis genus, there's hemp and there's marijuana. Really, they're almost indistinguishable. In fact, they are indistinguishable. The only thing in cannabinoids that differentiates cannabis from being hemp or whether it is marijuana is whether its primary ingredient, as you see on the left, is the cannabidiol or the CBD, or if its primary ingredients, which you see on the right, which is the marijuana, is THC, tetrahydrocannabinol. So we all heard of that. That's what makes you high. So if it has a THC content that is less than 0.3%, it's hemp. If it has a THC content of 20% or greater, it is marijuana. And that is all that differentiates the two. Now you notice the CBD content in hemp is higher, double higher, but the THC content in marijuana is way more than double that of hemp. So to make this a little more complicated and confusing, we're going to take two species of cannabis, and in this case they are talking about THC levels of 20% or higher. So this is marijuana. Well, if you look at the sativa, they're taller and slimmer plants, and the leaves are longer and thinner. It gives you a head high. You are more alert. You're uplifted and euphoric. You have increased creativity, and it is best for daytime use, like before you go to work. The indica, on the other hand, is shorter and bushier plant. The leaves are shorter and wider. It gives you a body high. It relaxes you. It's an appetite stimulator. It's a sleep aid. It's a pain reliever. And it's best for nighttime use. So I don't know if you see where I'm going with this, but where I'm going with this is that I see a lot of the same marketing strategy from Clark Stanley. It's for everything. And I'm going to show you some more of that here as we move along. But it's not to say that botanicals or plants are not commonly used in medicine, and that there is not real medicine in this, because there is, and I'm going to show you that. But you got to think, okay, just going through a very short list. You've got the angel trumpet, and that's a very powerful hallucinogenic, can be misused or abused, but that's where we get atropine and scopolamine from. Sweet clover, we get warfarin. Ephedra sinica, that's dual purpose as well as a decongestant, but it can be, it's the base product of methamphetamine. The coca leaf, it's to relieve hunger and fatigue. They chew the plants, or they chew the leaves, but it's also used for treating nausea and asthma. Coca tea is used for altitude sickness in the Peruvian Andes and elsewhere. And then you have penicillium mold. Okay, so there's in that world we get a lot and have gotten a lot of medicines, and that kind of medicine is really well accepted, I think, throughout history as actually having value. The question is cannabis, should it be used as it's shown here, or should it be the components synthesized? What really does work, what doesn't work? So again, you look at the economy, and economy matters. Hemp's on the left, marijuana's on the right. Cannabis sativa is the species. You see the psychoactive content, 0.3 versus 10%. The hemp is used for auto parts, soap, concrete. I'll show you some more things it's used for. The one on the right is used for getting high. That's its purpose. And look at the estimated domestic violence, or domestic market value, in euros. 452 million for hemp, 10 billion to 120 billion for marijuana. That's a big spread, but that's more than likely because a lot of it is underground money. But that's if you just took the low number, 10 billion versus 452 million, just take that, and that's a remarkable, I think that's a 20-fold difference. So that's quite substantial. And when I told you earlier that hemp and marijuana were essentially indistinguishable from each other, well, here's a photo posted from the New York Police Department 75th Precinct Twitter feed showing officers with what they thought was 106 pounds of marijuana. And they look pretty happy there, pretty proud. One guy's smiling. Other guy looks like he's got 2 bags. He's looking on this, holding them like babies. They look happy. But it was hemp. It was perfectly legal. Here is a U-Haul truck with a haul full of 3,300 plus pounds of marijuana. Guy spent a month in jail. Lab tests came back. It was legal hemp. So you can't tell the difference between the two. They're indistinguishable. So let's look at hemp in regards to what its history is. It is known to have over 50,000 different uses in textiles, industrial textiles, paper, foods, building materials, and body care. I mean, everything from clothing, soaps and shampoos, printing, newspaper, you name it. So it has a tremendous amount of utility and use. And again, the only difference is its THC content is 0.3% or less, just not enough to get you, to be worth getting, you have to smoke too much of it to get high. There's also evidence that there's material, though they've actually found material that dates 10,000 years made from hemp, and it is believed to be the first crop ever cultivated by mankind. And I thought that was sort of an interesting factoid. Its molecular structure between cannabidiol and tetrahydrocannabinol, which you see here, the cannabidiol is the CBD, which is the hemp, and you see it has an extra hydrogen atom. You look over at the hydrocannabinol, and you see that's missing. There's some minor other differences, but their molecular structure is very, 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 very similar. So what is the evidence of cannabis in health and disease? This study done from Israel. So cannabis preparations have been used in medicine for millennia. However, concerns over the dangers of abuse led to the banning of the medicinal use of marijuana in most countries in the 30s. I showed you that ad. They really felt it was a scourge. They didn't want to use it. In 1840, Schlesinger was the first apparent investigator to obtain an active extract from the leaves and flower of hemp. But it wasn't until 1964 that THC, the major, of course, psychoactive component of cannabis, was isolated in pure form, and its structure was then understood. Shortly after that was synthesized, it became widely available. These chemical advances led to an avalanche of publications on THC, as well as CBD, and the non-psychoactive plant cannabinoid. However, concern about the dangers of abuse led to the banning of marijuana and its constituents for medicinal use in the United States and many other countries in the 30s and 40s. It took decades until cannabinoids came to be considered again as compounds of therapeutic value, and even now their use is still very highly restricted. Although that's from this study, that's changed because marijuana is legal a lot of places. I mean, marijuana is legal. CBD is just legal. Marijuana is legal a lot of places now, so recreational use. And there's some questions about its safety, but let's get into the study because they discuss that. There is some dependency associated with marijuana. It seems to be more prevalent if they started early, but the dependency is also generally found in personality types of addicted people. It can easily be successfully reversed. There's really no major withdrawal symptoms. And it works on the brain, reward process, typical of all of these things, probably alkaloids. It's the dopamine receptors, as we see in most of these kinds of things. There are some negative effects to cannabis, and these can be related to alterations of attention and cognitive functions or other neuropsychological and behavioral effects. Again, found mostly if the person is either adolescent or began smoking in adolescence. That's kind of a key metric here. I would say, like drinking, our drinking age is 21 for a variety of reasons. Maybe that, as this becomes legal, we need to also, more legal in more places, we may have to make sure that there's some kind of age associated with them. People are going to get it. I was getting alcohol when I was 13 years old. There is some electrophysiological measures have revealed long-term deficits in attention among cannabis users, impairment in both cognitive function and mood following cannabis use. However, as it says here, the other studies did not really support that. So there's not strong evidence that you really have electrophysiological or cognitive or mood dysfunction with cannabis use. That just isn't there. There are some studies that have shown evidence that cannabis use may trigger an acute schizophrenic psychosis. That seems odd. I would say it's probably laced with something. Now, this was one that really got my attention. Amotivational syndrome. I don't really think that exists, but it was described in 1960 among patients with a history of long-time cannabis use. That sounds like one of those made-up syndromes, amotivational syndrome. So it's a stoner, so we're going to say he has amotivation. We have to give somebody a diagnosis, so that's it. The data from other studies, however, did not support this hypothesis. So again, the data is very mixed and it was very biased towards the time. Most of these studies were done at a time when the country was very divided between hippies and between preppies and, who used pot and who didn't and all this kind of stuff. But cannabis use, more abuse, can cause acute pancreatitis. Although the exact mechanism remains unknown, and this was published in 2007, and that's actually fairly decent evidence that it can happen. It's a very low percentage, but it can happen. Cannabis has been known for centuries to increase appetite and food consumption. We get the munchies, I heard. A friend of mine told me that. In animals, the CB1 receptor antagonism decreases motivation for palatable foods. And this was a very important study because they were able to take animals that there was indulgent food for them and there was good food for them. And if they used this cannabis, they were hungry, but they more preferentially went for the good food, but when they weren't high, they went for the more palatable food. So that was kind of strange, I thought. There is this drug, rimonabant rather, is a drug derived from cannabis and approved in the EU for weight loss. It also was very strong in increasing HDL, your good cholesterol, reducing triglycerides, and increase in plasma adiponectin levels, which that's very important for glucose control. Surprisingly, the U.S. Food and Drug Administration has declined to approve rimonabant, I'll say it right, primarily due to its slight potential to enhance anxiety and suicidal thoughts. I think that sounds like a crock to me again, but it's slight, they're not going to approve it. And there are a lot of people who this could potentially benefit because obesity, I think that carries, my view is it's probably going to carry a higher risk than is this drug. But there's also the concern about the litigious nature of our country, and that may be one of the reasons why they are not wanting to approve that drug. Because if somebody does commit suicide having been on it, it's going to be a class action lawsuit and the company will be out of business. So it's also very good for anorexia, especially for patients who have very bad nausea and vomiting associated with cancer and AIDS. So it improved their appetite very much as well. It's also very effective for anorexia associated with light weight loss in patients who also had AIDS, and increased appetite, improvement in mood, and decreased nausea. There is evidence that cannabis, specifically the THC, has been used in the past for as a pain relieving substance in our history. Evidence does suggest that it may prove useful in pain modulation by inhibiting neuronal transmission in pain pathways. However, again, these results do not support an overall benefit of THC in pain and quality of life in patients with refractory neuropathic pain. However, the first cannabis-based Sativex, which is a drug, has been approved for use for neuropathic pain due to multiple sclerosis in Canada. So there's not good evidence to suggest THC is good for neuronal pain, refractory neuronal pain, but with multiple sclerosis it seems like it is. And you'd have to dig deeper into these studies. My point of this I'm trying to make is that the evidence is very conflicted. It's not strong either direction. But if you're a believer, it works. And I don't think we can underestimate the placebo effect, but I'm not really sure. And getting high just feels good, I guess, so my friend has frequently told me. This is cannabis, an inflammatory mediator, autoimmune response, demyelination, and axonal damage controller or mitigator. It mediates it in multiple sclerosis. CBD has been shown to exert potent anti-inflammatory and antioxidant effects. And so if you think about cardiovascular disease, atherosclerosis is essentially an inflammatory process. So oral treatments with low doses of THC help to inhibit atherosclerotic progression in the mice model. So let's go back and do a full circle and talk about the benefits of marijuana as it is described in the current marketing literature. It fights cancer, anxiety and ADHD, relieves arthritis, treats migraines, treats glaucoma, epileptic seizures, prevents Alzheimer's, bipolar disorder. And you can see on the right more of that kind of stuff. Calms those with Tourette's and OCD. Helps relieve PMS. That's pretty impressive. That's an impressive item. Very impressive medication. Here we see health benefits of CBD oil. You can use it for, now this is of course for external use only, but it's been used for asthma. It's been used, again, I don't know how, you can't put it in an inhaler, I don't think. Cancer, brain, well-being, spinal cord injury, eyes, heart, intestines, stomach, bone structure. And here, this is a very interesting one because it talks about THC and CBD. So the THC is an orange dot, CBD is the green square, protects against cancer, both of them. Reduces nausea, both of them. Reduces pain, both of them. Causes drowsiness and increases appetite. Well, that's only the CBD. I don't know about you, but I've always heard that my friend, when he told me he got high, he got tired. So I don't know. I can't figure that out. Increases appetite. That's only the THC. Antidepressant, relieves spasms. I mean, you just go on. I'm not going to say any more about it. It's even an antimicrobial and an antibacterial. We shouldn't be washing our hands with, and that's the antimicrobial is the THC. We should be washing our hand. We should just be scrubbing with weed. I mean, really. So, I mean, it concerns me. It concerns me, you know, as just a citizen, as a parent, as a grandparent. I'm sure there's many of you out there as well. I think that before we embark on using these products, we have to really think about Clark Stanley. We have to go back and really consider what some people will do to make money. Now, do I think there are health benefits to some of the, if they could perhaps synthesize certain elements of it? Do I think CBD oil does have some benefits? I think it does. I think it does for certain things, but I don't think we know what those are. But I don't think it's good for fighting cancer. I don't think it's good for all these other things. Smoking weed, whether it be, now is it the CBD or the THC, I really don't know, that benefits people with glaucoma by lowering their intraocular pressure, but can that be given in a different way? Can we, I mean, like I said, plants and botanicals and molds and all of this stuff, we have extracted different substances from them for years. Look at the opium poppy. I mean, you know, the poppy where we get the opium from, and then of course the heroin. It really just depends on the extraction, the processing, a whole bunch of things that go through that. And so I think the substances contained in there do have value somewhere with some things, and probably even today have some value. If you have HIV, AIDS, or you have cancer and you're on chemotherapy and you're sick and you're retching and you can't eat and you smoke this stuff and your appetite comes back, then it works for you. And I think you should use it. Is there another way to, again, deliver it besides, you know, I mean, I guess they have edibles, but if you're throwing up, you don't want to eat edibles, so you have to smoke it. Is there another way to do this that works? Like a patch? I really don't know. I'm sure they're working on all these things. But to say that it does all of those things, which is in the contemporary, you know, sort of psyche of the public out there at large, I question the validity of all of this because the evidence is just simply not there. That's how I feel. So that's my talk. You get over the phone lines. John, any comments?
About this on so many different levels. Actually, I happen to know firsthand a lot of what you're talking about. Firsthand meaning close friends, family members, and you know, and it's all transpired in the last 12 to 24 months. I have friends who have serious cancer. And I have also, well, I can tell you a quick story about really something I don't think you mentioned. I don't know if you did, but you know, a lot of this research started in the veterinary world, actually, for animals.
Mm-hmm.
The CBD, I'm talking about the CBD. I'm not talking about, I don't know much about, first of all, nothing to do with smoking, and I know all the benefits. It helps some people in certain ways. The psychosis things are actually beneficial, seizures, people, appetites. But let me tell you what I do know firsthand, because I have friends that have done it and are doing it. I had last year a very close friend of mine who was diagnosed with a golf ball sized cancer on his liver and in his lungs, out of the blue. And immediately was swept away to say, you need, you know, the cancer treatments of today, radiation and chemotherapy. He said, let me think about it. He made some phone calls to another friend of mine who had, I guess, connections. My friend went out to California or Colorado and got with a very serious, like you said, the refinement and the way that the CBD oil must be distilled, I guess. It has to be done correctly. There's so much out there now because it's not highly regulated. People are taking all kinds of stuff. You have no idea. If you get the proper stuff, and the point is, you were talking about different avenues of administration. When you have cancer or when you need high doses, I'm talking of CBD, non-THC, you need it to be given the correct stuff, and it needs to be given to you in a suppository, not just 2 or 3 drops under the tongue. That is good also, by the way. I have friends doing that. And I had a friend did the high-dose THC that the place that he went to recommended under a doctor's care also, by the way. Took the CBD for 6 weeks, twice a day, through a suppository, came back to the doctor. Both cancers on his liver and lung vanished, gone, not just shrunk 50%. I know a number of people like that too. Now I do know it's helping people with their symptoms enormously. If you have radiation and chemotherapy and you take the high dose suppository, it makes the person feel a lot of the things you listed there, feeling a well-being. They don't have the nausea, their attitude, their outlook on life, enormously improved. I know a friend who's been doing this now for 3 years and went off it for a few months, drastic change, could hardly get out of bed. Went back on it, drastically back up, gardens every day, and basically the person is extremely terminal and has got cancer everywhere, but the way that it makes this person feel is remarkable. I'll tell you another quick story. We have a little dog. We have a Yorkshire Terrier mixed with a Shih Tzu. 2.5 years ago, he's not very old, only 7 years old. One of his legs, he just wouldn't, he's almost stopped walking on it. He would hop around on 3 legs, barely put the one paw down, and I noticed it. We went to a vet. The vet took x-rays, said he's already developing early stage arthritis. And they gave us the typical pills for arthritis. What do you call it? The things all runners take.
The COX-2,
yes.
The COX-2 inhibitors.
Yeah. High dose. Didn't touch him, wasn't helping him. I went online and bought some other stuff to add to it. Yeah, and it wasn't touching him. The dog got to the point where he hardly would even want to walk around. He just lost his activity. He was gaining weight. Went to another vet. We moved to another town. As you know, I'm a traveler. Went to a veterinary. Said the same thing. Said, well, he's just got early stage arthritis. And so we were reading, and we went to, like you said, the CBD is basically legal everywhere you go. And it's in almost all of your grooming and pet stores, by the way. Again, you have to buy the right stuff. What we did, we give him 3 drops on 1 treat a day. Joe, this dog is a new dog.
Yes, it does have anti-inflammatory properties. It does, but it has to be, you know, you in that setting on that dog, right? And I think that these stories are true. I don't doubt any of it at all, but you can't have something that works like that. But if the dog developed, let's say, diabetes, it's going to work on that too. The dog became, I don't know, had some other, one of these other syndromes that I had on there. It's going to work on that. or, got renal failure. It's going to work on that. I mean, you look at the list, John, and
Yeah,
it's
I don't know.
it's a little bit on the ridiculous side. I mean, be frank with you.
I'm just telling you, and so
it's
I
an
can tell you
anti-diabetic. It says it right there. And I'll tell you something that's very important that people need to know is CBD, if extracted, CBD itself has no psychoactive properties at all. So if you extract it from hemp, it's legal. But if you extract it from marijuana, even though it's just CBD, it's illegal, which is crazy. Now, the hemp has a higher concentration of it, and CBD is the same thing. It's the same CBD because it's essentially the same plant. But it just, that was a side. But I think that, I think it does. I think the anti-inflammatory properties are there, but it has to be used properly in the right setting for the right problem. If you have psoriatic arthritis, which can cause enormous problems in your joints, and people decide, well, this works, this is what I'm going to take. You may feel better for real. You may feel better because of placebo effect. We don't know. It's never been studied, never been proven, never truly been vetted out. Or you may end up with a far worse disease than had you gone and gotten conventional medicine and not just relied on what could potentially be a good product for some things. I'll bet you Clark Stanley's ointment worked for people because there was huge demand for it. So people thought it worked, John. Can't argue the point. And there was a tremendous amount of resistance to take it off the market. And it didn't have anything in it.
There's an 18 to 22% placebo effect with anything. So anecdotal, you have to take with a grain of salt. And I'll tell you, last two things. I have two very close family members who had, one guy, he's about our age, he had an old football injury in his knee, and it's hurt him forever. And he works through it. He's a construction guy. And somebody else I know had a similar problem, just acquired over time as a foot orthopedic. I was going to a foot orthopedic person for a long time. Under the tongue drops, again, you have to get the proper stuff. Both people who were dealing with a lot of pain chronically, it is completely taken it away 100%. Now, when they go off of it, or in fact, one of my friends who has the knee problem decided, because he doesn't live near me, he decided, I ran out, I'll just go to the store and get some other one. And he got some other one, and guess what? It didn't help him at all. He had to come back to getting, I just happen to know a really good producer of this in Colorado, and it's under medical advice. You have to talk to a doctor and so on. And he does the pure, healthy, best distilled product of CBD. And, these are 3 or 4, 100% of my experience. And I don't need it personally, I don't have any issues, but everything that I've seen, it's all developed here in the last 12 to 24 months, has helped. Now, I know several people who've tried it and several of their pets that they've tried it, and it did not help them.
Yeah, it's just hard to say, concurrent treatments with that and something else, or just that, and it just happens to work for them. You have to have the right cannabinoid receptors, right, in your body in order for them to work. Is there something that, turns those on or makes them more receptive or less to, the administration of that medication? I simply, again, I don't know. But I do know that the research that's going on now may help to answer some of these questions. But I think that as a cure-all for 100 different diseases, and all you have to take is either this or that, seems pretty far-fetched to me and irresponsible in regards to informing our public, our citizens, about treating themselves with what could be potentially, in their case, snake oil. Now, in somebody else's, it may be great, but I think we need to get science to vet this stuff out.
And finally, I think here in the last few years, I think that's happening, and it's always damaging to any medicine or product or any whatever that comes out, and it seems to cure some endless list of things. I mean, that's not helpful. Whoever thinks that they're helping promote their product or their item by saying, there's almost nothing, it doesn't help, is almost completely shot themselves in the foot, because it's just not possible.
Well, no,
one.
They don't.
Nobody's
it works.
It's
not true.
And therefore, your product falls on its face.
People are desperate. They see that big long list. Look, they saw that big long list on Clark Stanley's product. I mean, it was for everything from lame back to toothaches. I mean, it was everything. And so it didn't hurt him. In fact, he was a rich man, very rich. And so that's, I think, what happens is that the money interferes with good public policy. And I think that's potentially happening. I'm not saying it doesn't work. I'm just saying that there is very mixed evidence as to the benefits and risks of, in particular, THC. I think CBD carries with it extremely low risk, if any. And so I think that's worth taking, even whether it works or not. I don't think it's going to hurt you. THC, on the other hand, I think is a different thing altogether. So, but I don't think people should also believe that this is a panacea, that the CBD oil under my tongue is going to, it cured his cancer, it will cure mine. Or it will solve my alcoholism, or it will do something else. Because now, if it does, and it has a placebo effect on an alcoholic and they stop drinking because of CBD oil, look, great, take more. That'd be fantastic. But does that mean that really is what did it? And clearly the answer to that, I think we both agree, is no. There's no proof.
Back in the days of the gentleman you were talking about there in the history, because placebo effect is 18 to 22% of anybody who takes anything will have the suggested effect. Without the media and all the other things to downplay it and stuff, word could get out very powerfully that I took this thing and it did such and such for me. And the placebo effect has been around forever. And I do, back to the one person I know who's actually been taking the high dose CBD oil with suppositories for almost 2.5 years now. It has not cured this person's cancer, but it has made them feel enormously better, and the coping aspect of it has been hugely improved.
And I think that's very important. That's very important and very worthwhile, definitely. Definitely something that, and I'm glad for that, certainly. Regardless of whether it's placebo, which I don't think it is, I actually think it does work. I think CBD has medicinal value. We just don't know how much. Maybe there's something else to it that needs to be synthesized or extracted. Maybe it has to be in combination with something else that we're just not familiar with yet. The route of administration may have something to do with it, how long it lasts, and whether it can be time released. And there's just so many factors involved with developing and delivering medications that you just can't say 3 drops under the tongue works for everybody for all of this, and that's it. I think we just don't know enough. But I think it's an anti-inflammatory? Do I think it's an antiemetic? Do I think it works to help people's appetites that they're in? I think the evidence for that's strong, and I think it does.
There's some pretty good neurological evidence in the area of seizures and things along with some psychological disorders. I know of in children, and maybe true in adults too. Under a doctor's care and given whatever it is you're supposed to take, whatever route you're supposed to take it, and whatever dose you're supposed to take. I mean, if you just go off half-cocked willy-nilly, like you're saying, I'm just going to take this, and I'm never going to have a heart disease or kidney, whatever you think is going to happen, you have no idea if you're doing anything. But I mean, there's a lot of neurologists and people out there that really study the medicine part that are showing that So, but the studies need to emerge. We just don't. It's very hard to say.
Right. I agree. I agree with you. There needs to be evidence, right? I mean, at the end of the day, there just needs to be evidence. Either the anecdotal evidence seems strong, but I mean, there's really just no hard, fast, concrete evidence And I understand that absence of evidence is not evidence of absence, and I get all of that, and sometimes it's very difficult to do these kinds of studies. But I don't see this as being that hard of a thing to actually study. So I do think that evidence should exist, and should exist now or in the very near future, supporting the use of cannabinoids for various different diseases that have enough power and weight behind them that people can say, yes, this is an appropriate use for this medication. I think it's going to take some time, John. That's how I think. But of course, it's legal, so people can use it how they want.
Let me ask you about the motivation aspect.
Motivational syndrome. That's a good one.
Yeah, for people who smoke, just the regular guy on the street who smokes marijuana. Now, you know, I would tend to believe there's some pretty strong, and most of the people that I ever knew that smoked frequently, they definitely had issues with motivation. However, I will tell you about 2 seasoned adults of age who smoke marijuana from morning to night like they're cigarettes, and they thrive in their jobs and have no issues whatsoever. Mm-hmm. I know 2 people in my life like that, but I would say the vast majority of young kids that I knew when we were doing it, they suffered from some significant amount of what I would call amotivation. So whether that's anecdotal or proven or not,
but that just may be their personality, and they gravitate to that drug because it reinforces their underlying psychology. You know, we don't know, or it's because they started using it at an earlier age. Remember, the studies sort of reflected that. They started later, it didn't have that same neuropsychological effect. And so I think those are good questions. There was a question by Karen Perfusion. It says, do users of these kinds of therapies, more specifically probably the THC, not the CBD, but do they require larger amounts of hypnotics, muscle relaxants, and drugs when exposing, when they're going under anesthesia, basically? Do they require a higher level of anesthesia like you would find with chronic alcohol abusers?
Well, I don't know the answer to that, but I know that we probably treat a lot of people in cardiac surgery nowadays that are frequent marijuana smokers, and I have never heard that, but I am not an expert. It's a good one to ask. But what are your thoughts about that?
You know, I don't know. Intuitively, without, I mean, and I'm just giving this as my best guess, I wouldn't think so. I think it's a different mechanism of action. So I don't necessarily think it would work. I think most of what they give don't really go to that same center of the brain, and certainly not with the paralytics. It's not going to have that effect. So I wouldn't think so, but I don't really know the answer, Karen. But if you send me an email to contact@perfusioneducation.com, I'll find out the answer and email it to you. So if you do that, I'll get that answer to you. So I'll ask an anesthesiologist probably if do they know if this would affect their anesthesia regimen or plan on a patient who is a chronic marijuana smoker or brownie eater or edibles or marijuana gummy eater or whatever else. I mean, it's amazing to me at how simple it is to use these substances now.
Yeah, I mean, it's really exploded on the scene here in the last 5 years, or even the last 2 years, with the accessibility of and the packaging that they've come up with. It's just mind-boggling.
Yes, absolutely.
And the administrations of foods and whatever they come up with, it's just about out limits of the imagination, really.
And that's what concerns me, John. There goes the thing. This is, I guess, I'm sort of really giving almost a social science lecture here versus just but I hope it was entertaining at least. My philosophy is just my philosophy, and I respect that you may feel differently than I do, but I do feel there is some value. I just don't think that value is really well understood, and I think that it's like a lot of things, it's being marketed in a way that is attractive, and perhaps making claims that can't be supported by evidence, and therefore I believe there are desperate people who may be hurt by it, and that concerns me. And that's just my philosophy. Doesn't make me right, but it's how I feel. And I respect anybody that feels differently, because I think people have the right. We are a free will society, and they have the right to make whatever decisions they want to make and live free. So, that's how I feel.
Well, I think one thing is pretty conclusive, and that is on the young person developing brain, and probably have to stretch that to at least 19, if not 21, maybe in some people's cases. But for a 13, 14, 15, all the way through 18-year-old young person to be smoking it with any type of frequency, they're kidding themselves if you think that it's not harming the permanent long-term development of your brain. There's so many studies on that have shown it. I know that people don't want to hear that, and people don't want to believe that, but I think there's a ton of evidence.
I think the same thing.
I don't think there's ever been a study that has shown that wasn't the case, actually.
It's the same with alcohol. It's the same with, pretty much any drug. When your brain is developing, you don't need those things being added into the mix. It just confuses all of the processes that are taking place. So listen, with all that said, I hope it was fun at least. Your talk was fantastic. And I will look forward to seeing everyone tomorrow. We're going to have Dr. Simpkins on, and he is going to be talking. What is the title of his talk specifically? Do you have it? Let me get the title, because it's a really good title. Yeah, it's a novel approach for. Let me just pull it up so I say it. I don't mess it up. And tomorrow's Wednesday. Novel approach for treating vasoplegia syndrome and shock. And he has a nitric oxide absorbing material. And I'm going to ask him tomorrow whether or not, and I haven't asked him already, and he's probably not watching now, so I feel like I can say this. I won't preview it to him, but I want to know about, if you remember the perf web we did with Dr. Platt when he was talking about his heme particle, nanoparticle, that was basically heme in a glucose molecule that was very, very small. It was a nanoparticle that could be infused and perfused through clots, very good for ARDS, all of these things, because that molecule was able to move more freely. So it was like if you had an acute occlusion from a thrombosis, this particle could make it through that clot and perfuse the distal tissue, so you would reduce the size and damage from the stroke. And of course, that was an interesting talk. He was certainly very smart. And I don't know where that's going to, but it's interesting technology. So it was essentially an artificial blood that was different than what the other ones previously designed were and how it worked. So it was unique in the sense that it was this heme and glucose molecule. And now Dr. Simpkins is talking about excess nitric oxide production and how to control that, which is thought to be the cause of vasoplegia syndrome, which will lead to shock, of course, and being able to clear that is very beneficial in those patients. And he's a really super smart guy, been working on this project for probably 20 years. I know him very well. And he's a wonderful person, wonderful presenter. So I'm looking forward to his talk tomorrow. So maybe you could tune in, John. It would be great if you could, and maybe ask a question, because I'm sure I'm going to have a lot of questions for him too.
Well, are you ready for this little bit of news?
Yeah.
I've been working on my thesis, and my thesis is vasoplegia following cardiopulmonary bypass.
Well, I'll bet you'll watch it. I'll bet you we'll watch this program then.
Oh, I'm going to watch for sure.
Absolutely. And you too. You should watch it too. All right. I want to thank everybody. We'll see you tomorrow from 5 to 6 Central U.S. time. It'll be Dr. Simpkins, Novel Approach for Treating Vasoplegia Syndrome and Shock. I want to thank everybody for joining us. If you have any questions or comments, please email them to me. I promise I will respond to them. And we will, John, I can't thank you enough again. You're a gem, and I appreciate everything that you do for us. And I'm looking forward to seeing you again. And congratulations on the thesis. Hopefully you'll be able to, after you have had your opportunity to defend that and you get your degree, you'll be able to share that thesis with us on this program. I would really love that.
Well, it'll be about a year from now, so it'll be great education for all of us tomorrow, and I'll be definitely tuning in. I'm probably calling it.
I appreciate that so very much. Okay, everybody, see you tomorrow, same time, same station. Good night.
The point of care program at Huntsville Hospital is approaching its 20-year anniversary. As we began to grow as a hospital and provide more complex services to our community, the need for point of care testing became very clear in our organization. Many of our departments consider the EPOC device to be crucial to their ability to quickly move their patients from entry to the hospital to procedural room. It helps them monitor the patient's status during their procedures and post-procedure, so it's very integrated into our entire continuum of patient care. If you have any patient population where blood management is crucial, then a point of care device is very useful in those types of settings. It can provide a quick result on a very small amount of blood, and that is really important in some of our patient population.
We are starting a new process where we're going to screen our patients on the floor for sepsis. The patient can look and actually feel okay. They will show us signs and symptoms of sepsis. So what we do when they show these signs, we get a lactate level.
Lactic acid is a product of the sepsis cascade. So with sepsis, the inflammatory light switch goes on, the cascade starts churning, and unfortunately, once it starts going, we have to stop it. It will not stop on its own. The faster the lab draw, the faster the lab results, the faster you can act on it.
The process in the lab is what the process is. It just takes a certain amount of time for the instruments to run those tests.
I mean, we're talking 30 minutes even on a stat because that's the process. That's just how long it takes. There's not really anything you can do about that. For every hour you wait to give an antibiotic, the mortality for that patient increases 8%. So now that we have the handheld device, the nurse can get those results within a few minutes, and we know how to treat that patient. If a patient is going into septic shock, we do not have minutes to spare. We have got to get it done quickly. So when you get the little beep from the EPOC that says your results are in, you go with it. You don't even think twice about it. You're like, this is good. This is what I'm going to do for this patient. The next steps are clear.
I think our mortality on the initial floors dropped by almost 50% in the first 3 to 6 months. At this point, we're about hospital-wide. I think we'll be hospital-wide another 2 to 4 months. So this has become a huge program within our system.
Without the EPOC device, it would really be hard for us to get everything done in the timely manner. So it's really helped us to get our program going.
I mean, whether you're a surgeon, whether you're a medicine doctor, whether you're a dermatologist, you want to be able to do things in a timely fashion so that you can be most effective.
This really makes a difference in patient outcomes.
Mixed cannulae, expanding performance standards. High-performance cannulae for direct and femoral cannulation in minimally invasive cardiac surgery. LivaNova's complete range of mixed dedicated products allow easy and reproducible procedures. The portfolio includes the sutureless aortic valve Perfusion, Memo 4D for mitral valve repair, the HeartLink system for assisting the perfusionist in applying goal-directed perfusion therapy, and a broad choice of high-performance dedicated cannulae. LivaNova's range of cannulae suit every cannulation technique for minimally invasive cardiac surgery. Venous and arterial femoral cannulation can be performed using the WRAP venous cannula and the EZ-Flow Duo. For arterial direct and venous femoral cannulation, the EZ-Flow aortic cannula and the WRAP are available. For venous femoral access, the LevaNova Wrap Cannula features a dual-stage configuration for optimal drainage of the inferior and superior vena cava without interfering with the right atrium. The high-flow dynamics of Wrap improves the capability of drainage with a low pressure drop. An optional Sellinger dilator kit is available to perform percutaneous insertion. The LevaNova EasyFlow Duo Cannula is designed for a safe and smooth femoral arterial cannulation. Its conical dispersion tip design allows a more gentle flow in the femoral artery, and its red cap avoids blood backflow during obturator removal. A dilator kit for percutaneous insertion is also included with the cannula. EasyFlow cannulae are designed for safe, reproducible, direct aortic cannulation and include a malleable stylet to aid cannulation insertion, facilitating bloodless introduction into the aortic arch, as well as a special conical dispersion tip for a more gentle flow in the vessel to reduce shear stress.
Like all perfusion professionals today, we are busy and frequently short-staffed. Does taking time off for a conference create a burden for your teammates? Has reimbursement for your continuing education dropped? Have you priced the cost of going to a meeting lately? Registration fees, airfare, transportation and parking, hotel, and meals out? This totals up to having an out-of-pocket expense of over $2,500. And then you hope the content is good. Perfusion Education has heard your concerns. They have a simple and seamless system that works on any platform, computer, tablet, or even your phone. You can chat during the program or even phone in and be live on the air. The content, second to none. Perfusion Education is by perfusionists and for perfusionists. Create a free account and check us out today.